Hello students, in the previous video we had seen the meaning of operation research and a little bit about the history of operation research, its application in the field of industries and in some other areas. I had also given an activity to search, hope you have done it. Then we saw various techniques of OR and algorithm of operation research from formulating the problem to implementation. Okay, so in this class let us learn about linear programming. Linear programming is a method to achieve best outcome such as maximum profit or minimum loss in a mathematical model whose requirements are represented by a linear relationship. Linear programming problem consists of three parts, namely objective function, set of constraints and non-negativity restrictions. As you can see here, this is the general form of linear programming problem. This part is the objective function, the value of which is to be optimized. That means minimized or maximized. This represents the set of constraints. Constraints means some conditions. Here you can see the relation is written like this. It means it can be either equality or inequality, that is less than or equal to or greater than or equal to. We have to choose such exercise that satisfies these constraints and gives optimal value for the given objective function. This we call as non-negativity restriction. Non-negativity means it should not be negative. Please note that it can also be 0. Here exercise, that means x1, x2, so on up to xn. Xi's are called decision variables, Ci's are called objective coefficients, Aij's are called technological coefficients, Bi's are called resources. Okay. We can understand the meaning of these terms while doing problems on LPP. Now consider an example. See, this is an example. Maximize z is equal to 8x1 plus 5x2 subjected to the constraints 5x1 plus 10x2 less than or equal to 60, 4x1 plus 4x2 less than or equal to 40 with x1 greater than or equal to 0, x2 greater than or equal to 0. Here the objective function is maximize z is equal to 8x1 plus 5x2. It is the objective function. And the set of constraints is this part, these inequalities. Here the inequality is less than or equal to. And this part is non-negativity restriction. Now identify the decision variables, objective coefficients, technological coefficients and resources in this example. As you can see here, x1 and x2 are decision variables. 8 and 5 are objective coefficients corresponding to x1 and x2. 5, 10, 4 and this 4 are technological coefficients and 60 and 40 are resources. Formulation of LPP. Formulation of LPP is a process of converting real world problem into mathematical terms. That means translation of the problem from common language to the mathematical language. It is very important step in the methodology of OR since it acts as the foundation for the derivation of the solution. In the next video, we shall try to solve some problems regarding the formulation of LPP.